bombed the city and the ships in the harbor. Dr. Stuart Alexander noticed people died in the first few days. But 10 days later, another peak of people died. He also smelled garlic in the air. There was nitrogen mustard. But importantly, in the second peak, he noticed the lymph nodes of the patients were smaller. So Goodman and Gilman said, if nitrogen mustard is the German First World War chemical warfare, but we have to save our patients. So nitrogen mustard was given, and this is the beginning of chemotherapy. That means they are poison. But our patients need to be saved by poisons. Of course, it became better over the years, but now we know chemotherapeutic agent is very important, but no more progress because of the toxicity. Now, if we know what causes cancer, we can design drugs to hit them. It's like a horse pulling a cart. This is cancer. These are the horses, and the green colors are the horses. So for the last 25 years, scientists and doctors discovered what are the horses that cause cancer, or called oncogenes. And scientists and pharmaceutical companies made drugs. The first drug was actually cloned by Dr. Lisa Cousin, and Genentech found a way to treat it. It's a community. We work together. But now, all the targets are gone. Millions of patients' genome has been sequenced. We know what's there. There are no new ones. So what is next? Fire and water are good servants, but bad masters. This was quoted a very famous Greek philosopher. So when fire is on and water is not on, over a period of years, cancer starts. They go down 3 paths. One, the metabolism of the cancer cell change. Second, they cannot repair the 2 billion base pairs of DNA. And finally, the immune system protects us. We and others discovered some of the genes, that are involved in cancer in metabolism. We think of eating food, glucose. There are 2,500 genes controlling glucose, ketones, etc. One of which was discovered by Bert Vogelstein's lab in brain tumors. And our lab, together with French lab, discovered this in lymphomas. So, very recently, two very talented French doctors, Julie Licker and Francois Lemonnet, we worked out that these mutations of metabolism was not the cancer becoming cancer, but it was throwing a party to have all the other cells come in, and over time got out of control. But as Dr. Burns said, we were lucky. With Agios, the company that we co-founded, Lou Kentley at Harvard, Craig Thompson in New York, we developed drugs. These are the patients who do not respond. These are the patients that respond a little bit more. They live a few months, and some patients live one more year longer, and miraculously, a few live much longer. This is leukemia, end stage. Now, the most difficult treatment is brain tumor, also have this mutation. And the company, Agios, is now a French company called Servier, and they just reported 2 months ago that even some patients, about half of them with brain tumor, responding to the drugs. Very lucky. I'm Chinese. I can say Confucius. Confucius said, we all have 2 lives. The second one begins when we realize we only have 1. Now, why is that important? Because we are a family that have seen cancer, that have suffered in cancer, but also conquered cancer. Today, 50% of cancers are cured, but more cancer is arising because we live longer and some bad practice. Pancreatic cancer just killed a very close friend of ours last week. And Dr. Lisa Cousin and I, in fact, she is going to go to Scotland for the funeral. Modern medical scientists have 2 lives. The second one begins when they realize immunology, our immune system, who is supposed to protect us from viruses and bacteria, is the orchestra for most life symphonies. Immunology was developed because we have to fight virus. We have to fight bacteria. We have to fight parasites. 100 years ago, the average life of people even in Europe, was only 30 years. Nobody lived past that. Very few. Immunology is a system that fight. But sometimes they fight yourself. You get autoimmune disease. Sometimes they fight yourself. You get neurodegenerating disease. And sometimes you get cancer. What is the key of killing yourself and killing cancer and killing bacteria and viruses? The key is this molecule, the T cell receptor. It is the sensor that says, where is the virus? Where is the cancer cell? This is a piece of the virus. It is COVID-19. This is called HLA, given to you by your parents as a flower pot to present the flower. The T cell receptor comes in and say, is this part of your heart, your liver, your kidney, or COVID-19? Start, kill. And very recently, the scientific world discovered that this piece can also be cancer. We have to find that. But before then, we have to find what is the sensor? What is the T cell receptor that says, virus, kill. Your kidney, don't touch. So, almost 40 years ago, we were very simple-minded. We discovered the T cell receptor by a simple subtraction. It's like, what can be the T cell receptor in the T cell and what cannot be? This was done by a Japanese doctor, Yusuke Yanagi. Very fortunately, this is me, I can't believe it. Look at the hair. And Mark Davis, 30 years old, independently discovered the key to saying, virus, kill. Liver, don't kill. Kidney, don't kill. Cancer, kill. So that is known. And how do you study something so complicated? You make genetic mice. Mice without each one of these genes one by one. And this is CTLA4. Paul Waterhouse, a Canadian doctor in the lab, found out CTLA4 is the brake. T cell receptor is the key. CD28 is the accelerator. Start the car, boom. You go, boom. Stop. But I never thought, but this was the beginning of curing cancer by immunotherapy. I was cursing the darkness. Oh, it won't work, it won't work, it won't work. Jim Allison, who won the Pezcoller AACR prize a few years ago and has won the Nobel Prize, he said, he lit the candle. You can see we are best friends. He put an antibody on the brake, and the car will not stop and kill cancer, kill cancer, kill cancer. This graph came from Dr. Lillian Siu in the front row. You can see that many of the cancers, very strong response, 50% end stage, no more to do the T cells kill the tumor. Some are so long, 10, 15 years now, can be considered cured. There's still a lot of work to do. And of course, both of them, including Tosco Honjo, who found another break called PD-1, went on to win the Nobel Prize, and we are all very happy. But how do we improve? 2,000 clinical trials combining different drugs to get a better response, better than 20%, longer than 3 years of survival. Make it 10, make it 20. Complicated, very complicated. Dr. Lisa Cousin is an expert on these macrophages. They are very important. Well, 2 Italian descendant doctors, Pellegrini, Calsausa, they discovered what can make the T cells. The T cells been killing tumor, killing. I'm tired. They say, you give now interleukin-7. By giving interleukin-7, the mouse lives 100 days. More, which means years for humans. What about something really mysterious? Here is the tumor, is the cancer, and look at these T cells. The T cells trying to get in, right? These are T cells. They're coming in to kill the tumor. The tumor built a wall. And this wall reminds us of Helen of Troy. There is a wall. The Greek soldiers cannot go in. And what is that wall? And what is the Trojan horse? The wall turned out to be macrophages, like what Dr. Lisa Cousin is very known for. But who is the Trojan horse? Completely unexpectedly, the Trojan horse comes from a message from the brain. This is Science Magazine's News and View. It says, Tak Max Lab discovered the immune system thinks. When we deleted, when me, an American postdoc, deleted the ability for the T cells to make a neurotransmitter. A T cell make a neurotransmitter. Brain needs neurotransmitter. T cells don't make neurotransmitter. No, they do. And together with Kevin Tracy in New York, we discovered that 10 years ago. But when she deletes the gene that cannot make neurotransmitter, you see that the yellow boxes are the virus in a mouse that cannot make a neurotransmitter by the T cells. Totally unexpected. So it's kind of like the T cells bring its own key, open the door to get out of the blood vessels. You can see much smaller. Well, miraculously, this also works, looks like very preliminary data in patients. that you can see here, this blue line up there, are patients with high choline that have lived. And if you don't have high choline, you die faster. So there's not to be done. My final 2 minutes, I'm going to talk to you about going back to the beginning. Sometimes when we go on the road, we lost where we came from. The beginning. The beginning is the T cell receptor. Now, many of you have seen the movies James Bond, 007. Okay. Jason Bourne, another one. They would go into the enemy's quarters, go jumped out of the, boom, 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 killed. Right? They don't care. The enemy had tanks. They're not hurt. They go to the 20th floor, found the bad president of the country. Shoot him, kill. He jumped out the window, 20 stories, land on the feet. What am I talking about? Train, find the James Bond and the Jason Bourne and treat cancer with it. It's already been done. The work of Carl June, Michel Sederline, took a T cell receptor and hooked it up to an antibody, and leukemia and lymphoma, end stage, many are alive today, 10 years later. Drugs have been approved, but that's only leukemia and lymphoma. What about pancreatic cancer, breast cancer, prostate cancer? There you need what is called TCRT. Now you have to go find that little piece of the cancer, like the little piece of the virus, and use the T cell receptor, and you can see the beginning of another generation of James Bond and Jason Bourne. We can see all the cancers from here to there. This is the work of Aptimmune and Christian Henrich's lab in New Jersey. This is a virus cancer. You can see that's very dramatic. So my last slide is that with the help of a brilliant Japanese professor in Toronto, we are gearing up to make and find more pieces of cancer bad actors. We are finding more flower pots. We are finding more T cell receptors. And we are ready for the last one. Maybe. So, as you can see, who is this? What he said is, it's in Italian. Someone tell me? Yes. He said, we are all one-winged angels, but we need our friends and collaborators working together to have two wings. I'm lucky that in the last 40 years, I had 150 doctors and students working, and 10 came from Italy. That we recently got together in Germany just 2 months ago. This is Alessandro Ruffini, a new professor in Milan, Chiara Gorini, professor in Leeds University, and Paola Capello in Torino. We are very lucky. There is an African saying. It says, if you want to go fast, go alone. If you want to go far, go together. Gracias.
Grazie al professor Mack. Adesso facciamo la photo opportunity davanti allo scenario del premio. Grazie anche per la sua narrazione comprensibile, eppure ha spiegato concetti estremamente complicati. E grazie anche per aver dedicato l'ultimo ringraziamento ai suoi collaboratori al laboratorio, come ha avuto modo di dire ieri citando un proverbio africano in conferenza stampa parlando ai giornalisti: chi va da solo va più veloce, ma chi va insieme va più lontano. E questo è un po' il motto del professor Mack. Bene, ci siamo, grazie. Chiediamo, gentili relatori, di accomodarsi, anche perché, come di consueto, prima di salutarci c'è un momento musicale e anche quest'anno sarà una sorpresa, ci auguriamo, gradita da parte vostra. Il momento musicale è con il coro Highlight, molti di loro lo conosceranno, è l'unica formazione corale della nostra regione, coro Highlight. Si tratta del primo musical theater choir del Trentino, cioè un coro che studia ed esegue il repertorio tratto dal teatro musicale anglosassone. Il coro Highlight nasce nel 2014 come laboratorio musicale e diventa associazione di promozione sociale nel 2017. L'associazione promuove la cultura musicale e di inclusione sociale attraverso workshop, concerti, eventi pubblici e collaborazioni con altre associazioni e realtà, sia trentine che italiane. Fin dalle origini il coro è diretto dall'attore e cantante Matteo Ferrari e accompagnato al pianoforte da Mattia Beber. Signore e signori, il coro Highlight.
Baba,